Okay, students, on this group we're going to be going over, for examples on how to find the inverse of functions, linear functions to be specific. Before we go over the examples list, I'm going to list the steps that we're going to use to find the inverse of these four examples. So steps, write this down. Step number one, um, rewrite your output as y equals whatever, okay? If it's f of x, g of x, f of whatever, you just write it as y. Changing from the f notation to a single variable. Step number two, you're going to switch. You're going to switch y's for x's and x's for y's. All right, that's what finding the inverse is all about. The output becomes the input, and the input becomes the output. Step number three, you're going to solve for y. Okay, and then last step, step number four, call your new y the inverse. Okay. Or you can name it. It's just a naming procedure, so just call it the inverse, all right? Okay, so let's go ahead and go over the four examples. Example number one. We'll actually find the inverse of the following. This applies to all four examples. So find the inverse of the following. All right, number one, what if we had the function f of x equals 2x minus 3? So first thing we're going to do is we're going to rewrite this using rewriting our output as y. So I'm going to write this as y equals 2x minus 3. Okay? So this is the rewrite step, step number one, which is to rewrite. Okay? Now what I'm going to do next is I'm going to make the switch. I'm going to switch my x's for my y's. So let's write down the steps. So the next step is to switch your y's for your x's. So how do we do that? Well, instead of y equals 2x minus 3, I'm going to have x equals 2y minus 3. All right? Step number 3, we're going to solve for y. When you look at this problem, it's a two-step procedure. We're just going to add 3 to both sides and then divide by 2. That will isolate our y. Okay, so let's go ahead and do that. Add 3 to both sides. Using the reflexive property of equality, we can write this as 2y equals x plus 3. Then to finish this off, we'll divide both sides by 2, divide by 2, and divide that by 2. So we're going to have the equation y equals x plus 3 over 2. All right, last but not the least, we're going to rename. We're going to rename it as the inverse. So since the original function was f of x, this is going to be f to the negative 1 of x equals x plus 3 over 2. All right? Okay, let's move on to example 2. What if we had the function f of x equals 2 over 7x minus 5 over 7? First thing we're going to do is we are going to rewrite, okay? Rewrite as y equals whatever, okay? So to rewrite this, f of x is y, so I'm going to write this as y equals 2 over 7x minus 5 over 7. And the next thing we're going to do is we're going to do a switch. What am I switching? I'm going to switch the y's for my x's and my x's for my y's, okay? Because when you find an inverse, the output becomes the input and the input becomes the output. So this is going to become x equals 2 over 7y minus 5 over 7. Okay, now the third step is to solve for y. Solve for y. Alright? This is going to be a two-step procedure also. We're going to add 5 over 7 to both sides and then multiply by the reciprocal of 2 over 7, which is 7 over 2. So let's go ahead and execute that algorithm. We're going to add 5 over 7 to both sides. So that's going to leave us with x plus 5 over 7 equals 2 over 7y. And then multiply both sides by 7 over 2. That's the reciprocal of the coefficient of y on the right side. So multiply by 7 over 2, and multiply this whole quantity by 7 over 2. Now, why did I choose 7 over 2? Because they divide each other out. This 2 goes here once, and 2 goes here once. 7 goes here once, 7 goes here once. Utilizing the reflexive property of equality, we can rewrite this as y equals 7 over 2 times x plus 5 over 7. Okay? Now what we're going to do next is distribute this to the both quantities in the parentheses. So we're going to have y equals 7 over 2x plus, multiplying top and bottom, we're going to have 35 over 14. This can be reduced by dividing the top and bottom by 7. Divide by 7, divide by 7. So our inverse, starting with y, is 7 over 2x plus 5 over 2. Okay? And then the last step is to rename our function. We're going to rename it as an inverse. So that's going to give us f to the negative 1 of x equals 7 over 2x plus 5 over 2. So there goes your final answer. Alright, let's go ahead and take a look at question number 3. Question 3, we have the function f of x equals negative x plus 2 over 2. We're going to start out by doing the rewrite step. Rewrite. So to rewrite this, we're going to write f of x as y equals negative x plus 2 over 2. Next step is to do the switch. We're going to switch the y's for the x's and the x's for the y's. So that's going to yield x equals negative y plus 2 over 2. Okay? Now, after doing the switch, the next thing we're going to do is we're going to solve. Okay, solve for y, and whatever we get for y, that is our inverse. Okay, so let's go ahead and do the solve. This is a 3-step procedure. We'll get rid of this 2 in the denominator, get rid of this 2 right here, and then the minus. To get rid of the 2 in the denominator, since we're dividing, we're going to multiply by 2, both sides. That leaves you with 2x equals negative y plus 2. And then subtract 2 from both sides. Subtract 2, subtract 2. And then you have negative y equals 2x minus 2. And then to get rid of this minus, we divide everything by negative 1. So divide by negative 1. Every single time, okay? So when you divide by negative 1, what happens is all the signs switch. So you're going to end up with y equals negative 2x plus 2. Alright? To finish this off, we're just going to rename our final answer as an inverse of the original function. So the original function was f of x. So our inverse is going to be f to the negative 1 of x equals negative 2x plus 2. And there goes your final answer. Alright, let's proceed to the final problem, question 4. What if we have the function f of x equals negative 5 plus 3 over 4x? The first step is to rewrite our function using the y equals blah blah blah. Okay? Let's do that. So f of x becomes y, so we're going to have y equals negative 5 plus 3 over 4x. The next step is to do a switch. Alright, we're going to do a switch. So let's write that down. We're going to do a switch. What are we switching? We're going to switch the x's, the y's for the x's and the x's for the y's. So that's going to yield x equals negative 5 plus 3 over 4y. Alright? Now, to finish this up, we need to now solve. The next procedure is to solve for y, and that will be our inverse. Okay? So to solve for y, we're going to have to employ a 2-step procedure. We add 5 to both sides and multiply by a reciprocal of 3 over 4, which is 4 over 3. Alright, so add 5 to both sides first. And then we're going to have x plus 5 equals 3 over 4y. Okay? And then to finish this up, we'll multiply by the reciprocal of 3 over 4, which is 4/3 to both sides. On the right side, you notice that 4/3 divides out. 4 goes here, 1, 4 goes here, 1, 3 goes here, 1, 3 goes here, 1. And we're going to use the reflexive property of equality to write it as y equals 4 over 5. Oh, I'm sorry, 4 over 3. 4 over 3 times x plus 5. Okay? Now we're going to distribute this 4 over 3 to both quantities in the parentheses. So our final result is going to become y equals 4/3 x plus, how do you multiply 4/3 by 5? You can just write 5 as 5 over 1, multiply top and bottom, so we have 20 over 3. And then to finish this problem off, we just rename. Okay? Rename y, the inverse, using the notation that was presented in the original question, which was f of x. So this is going to be, alright, so we're going to rename it. We're going to call it f to the negative 1 of x equals 4/3 x plus 20 over 3, and there, that is our inverse. Okay? Alright. Thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. More videos can be found on microserve.com. Thanks again and have a wonderful day.